Welcome to the Deep Dive. We're the place that takes those dense reports and studies, pulls out what you really need to know, and basically hands you the blueprint. Today we're getting into climate accounting. Now, I know it sounds a bit dry, maybe, but trust me, this stuff is critical. It's about whether net zero actually means net zero for the climate, or if it's just, clever bookkeeping. So our mission today, really unpack the difference between those long-lived greenhouse gases, CO2s, the big one, and the fast-acting ones, the short-lived climate pollutants, SLCPs. We're looking especially at methane. The sources we've got lay out some pretty clear principles, guardrails really, for how we can use methane reduction, for example, to maybe compensate for CO2 emissions without messing up our long-term climate goals.
Absolutely. And the risk here is huge. If you treat them as interchangeable, like 1 ton of methane reduction equals 1 ton of CO2 reduction permanently, well, you're ignoring the physics. You could end up in a situation where, on paper, a company or even a country hits net zero, but the actual global temperature keeps rising. Why? Because that long-lived CO2 is still building up in the atmosphere.
Okay, so it's a kind of accounting loophole that could have real-world warming consequences.
Exactly. And that's why our sources propose this framework, these 5 sort of high-level principles. Think of them as stress tests for any new accounting methods popping up. We need to make sure the precedents we set now, especially around this idea of compensation, are really solid, scientifically sound, durable.
Right. Let's start with the science then, the physics. What makes these SLCPs so different from CO2? You mentioned they're short-lived. How short?
We're talking gases and particles, things like methane, HFCs, those are hydrofluorocarbons, tropospheric ozone, black carbon soot. They stick around for maybe a few years, sometimes even just days or weeks. CO2, centuries to millennia.
Just a flash in the pan compared to CO2.
A flash, but a really powerful flash. That's the key. While they're up there, they trap a huge amount of heat. Far more potent molecule for molecule than CO2 in the short term.
So they're like climate sprinters while CO2 is the marathon runner.
That's a great analogy. Let's take methane, CH4. Its physical lifetime in the atmosphere is about 10 to 12 years. Then it breaks down chemically, but its warming impact, massive. We use this metric, global warming potential, or GWP. Over a 20-year window, GWP-20 methane traps over 80 times more heat than the same mass of CO2.
80 times. Wow.
Yeah, even if you look over the standard 100-year period, GWP-100, which is what most regulations use, methane is still around 30 times more potent than CO2.
Okay, so you get this intense but relatively brief warming spike from SLCPs, and then CO2, it's less intense maybe year to year, but it just keeps adding up and up and up for centuries?
Precisely. The CO2 effect accumulates, the SLCP effect is strong, then fades relatively quickly.
I can see why reducing SLCPs is attractive then.
Oh, absolutely. Because you see the climate benefit fast. Things like fixing methane leaks from oil and gas operations or capturing methane from landfills. Those actions can slow down the rate of warming pretty quickly. It helps lower the peak temperature we might hit this century, potentially gives us breathing room, maybe helps avoid triggering some of those climate tipping points we worry about. It's vital work.
And here's the core issue we're diving into. It's not the same as removing CO2 that will warm the planet for hundreds of years.
Exactly. It's fundamentally different physics. And that's where the accounting pitfalls come in if we're not careful.
Okay, let's get into those pitfalls. You said the guardrails are designed to prevent specific problems. What's the first big one?
Pitfall number 1 is about the metrics themselves. Short horizon metrics overemphasize SLCPs. Remember that GWP metric?
Yeah, global warming potential.
Right. It measures the total heat trapped over a set time, like 20 years or 100 years. It's not about the instantaneous power. Now, if you choose a short horizon, like GWP-20...
Methane looks incredibly potent, 80 times CO2.
Exactly. So if you're using GWP-20 to create carbon credits, a project reducing 1 ton of methane suddenly looks like it's offsetting 80 tons of CO2. If you use GWP-100, it would only be maybe 30 tons.
So just changing the time window drastically changes the supposed offset value.
By almost a factor of 3 in this case. That creates, well, perverse incentives. You might prioritize short-term methane fixes over longer-term CO2 solutions because they look better on paper using GWP-20.
And you're overstating the long-term climate benefit.
Massively. And even GWP-100, the standard used by the UN climate framework, the UNFCCC, our sources argue it still doesn't capture the true multi-century impact of CO2. It can create a false sense of security about achieving long-term net zero.
Okay, so metric choice is pitfall 1. What's number 2?
Pitfall 2 gets at the duration mismatch directly. Radiative forcing matching requires long-term commitments. Radiative forcing is just the measure of warming influence. So if you emit a pulse of CO2 today, it's going to keep warming the planet for centuries to truly physically counterbalance that entire warming effect using SLCP cuts.
You can't just cut methane once, right? Because the methane effect fades quickly.
Precisely. You need to make new SLCP reductions again and again, year after year, potentially for centuries, just to keep counteracting that single initial CO2 emission. Some call this horizontal stacking.
Horizontal stacking.
Okay.
So you cut methane this decade to offset today's CO2. The next decade, you have to find more methane to cut to keep offsetting that same original CO2 and so on.
For hundreds of years. And that leads straight to a massive problem, execution risk.
Who guarantees that? A company makes a net zero claim today based on this, maybe buys some methane credits.
Yeah.
But that company might not even exist in 50 years, let alone 200.
Exactly. Who enforces that centuries-long commitment? If the commitment fails, which is, let's be honest, quite likely over such timescales,
then the warming from that original CO2 just keeps happening, and the cost, the burden, falls on everyone else.
Yeah.
Future society, basically.
Correct. It's a deferred liability problem.
Okay, that's a big one. Pitfall 3.
Pitfall 3 is additionality and perverse incentives. This is classic carbon market territory. Additionality means the reduction wouldn't have happened anyway without the carbon credit payment. If the rules for proving additionality are weak, or if the price for SLCP credits gets really high, well, history shows things can go wrong.
You mean like gaming the system?
Yes. The infamous example comes from the Kyoto Protocol's Clean Development Mechanism, the CDM. There was this industrial gas, HFC-23, a potent greenhouse gas. Some chemical plants found they could get huge payments, huge numbers of carbon credits, just for destroying this waste gas.
Okay, seems reasonable, destroying waste.
But it became so lucrative that some factories actually started producing more of the primary chemical just so they'd have more HFC-23 waste gas to destroy and claim credits for. They were creating pollution to profit from cleaning it up.
Wow. That's the definition of a perverse incentive.
It really is. And the risk today, our sources warn, isn't just about fraud like that. It's also that relying heavily on SLCP compensation could actually slow down needed regulations, especially on fossil fuels.
How so?
Well, if it's cheaper or easier for a company to buy methane offset credits than to invest in decarbonizing its own operations, they might just do that. It could delay the essential structural changes we need. Worse, it could even, as one source puts it, catalyze the creation of more mitigatable emissions.
Like making industries less efficient just so they can claim credits for cleaning up later.
Potentially, yeah. It's a subtle but serious risk.
Okay. And the last one, Pitfall 4.
This one really ties it all together, balancing the books, but not the carbon cycle. Imagine a company using lots of short-term methane credits to claim they've offset their long-term CO2 emissions. Their corporate sustainability report looks fantastic. Their CO2 equivalent footprint might appear to be zero, net zero achieved.
But the spreadsheet looks good.
But the atmosphere doesn't read spreadsheets because the warming effect of the methane reduction fades quickly while the CO2 they emitted continues to accumulate. The actual concentration of CO2 in the atmosphere keeps going up.
So the planet keeps warming, even though the company claims net zero.
That's the core danger. The aggregate CO2e metric hides the underlying physical reality. It leads to poorer climate projections and masks the fact that we haven't actually stopped the long-term warming problem driven by CO2 accumulation.
Okay. Those 4 pitfalls, metric choice, duration mismatch, perverse incentives, and hiding the real carbon cycle paint a pretty clear picture of why just swapping tons isn't good enough. So how do we avoid these traps? Let's get into the 5 guardrails proposed by the sources. What's the first principle?
Principle 1 is fundamental, independent tracking of SLCPs from CO2. It sounds simple, but it's crucial. Even if you aggregate them into a single CO2 equivalent number for, say, high-level reporting, you absolutely must keep separate, distinct accounts or ledgers for the short-lived pollutants, like methane, and the long-lived ones, like CO2 and nitrous oxide.
So don't just lump them together and lose the detail. Why is that separation so important?
2 main reasons. First, transparency. It allows everyone, investors, regulators, the public, to see exactly what is being reduced versus what is being emitted. You can see the difference between a short-term fix and a long-term solution. Second, future-proofing. Climate science evolves. Our understanding of GWPs might change. Metrics might be updated. If you have separate ledgers, you can go back and accurately reassess historical claims based on the latest science. If it's all just one blended number, you can't do that.
That makes sense, like keeping receipts. Are there examples of this in practice?
Yes, New Zealand is often cited. Their national climate targets actually have a separate goal for reducing biogesic methane, mostly from agriculture,
Yeah.
alongside their main net zero target for CO2 and N2O. They recognize the difference.
Okay, separate trashing. Principle 2.
Principle 2. Radiative forcing should match the climate claim. This one really bites. It says the climate benefit you claim has to match the climate damage you're offsetting in both how much warming and for how long.
So if you're offsetting CO2, which lasts centuries,
Your offset action needs to deliver a climate benefit that also effectively lasts for centuries. A short-term methane cut just doesn't do that on its own.
so how do you make them comparable then? This sounds like it challenges the whole to GWP 100 standard.
It does. The implication is that if you are going to compare them, you need metrics that reflect the full timescale of CO2's impact. Some sources suggest using metrics like GWP over a 1,000-year timeframe, GWP 1000, or other approaches that account for the permanence difference.
GWP 1000 instead of GWP 100. That would make methane look much less valuable relative to CO2 compared to the current standard, right?
Much less valuable as a direct substitute for CO2 reduction, yes. It acknowledges CO2's persistence. This principle also means accounting systems need built-in rules to handle the time difference. For example, one carbon registry, the American Carbon Registry, has a protocol for plugging old, leaky oil and gas wells. They only allow credits to be issued for the methane avoided over a 10-year period.
So they explicitly limit the duration of the claimed benefit, acknowledging it's not permanent like CO2 removal.
Exactly. It's one way to handle the temporal dynamics.
Okay, principle 3. You hinted this is where it gets really interesting.
It is. Principle 3. Ensure accountability across climate timescales. This flows directly from the duration problem. If a CO2 emission creates a centuries-long warming liability, but the entity offsetting it, like a company buying methane credits, might only exist for decades, how do you ensure the offset's integrity over the long haul?
Right, the corporate lifespan versus the climate lifespan mismatch.
We need mechanisms that guarantee accountability beyond the lifetime of individual actors.
Yeah.
And this is where we can learn from how society manages other very long-term high-consequence risks.
Like what?
Think about nuclear waste. We build repositories like Onkalo in Finland, engineered to last 100,000 years. Those projects come with legally mandated long-term funding mechanisms, often set up decades in advance, to ensure they are managed safely long after the power plant that created the waste is gone.
Okay, that's a serious long-term commitment.
Or a more common example, mine reclamation. Governments routinely require mining companies to post bonds or put money into escrow before they start digging. That money guarantees the site will be cleaned up eventually, even if the company goes bankrupt.
So applying that logic to climate compensation.
It means if you're using temporary SLCP reductions to compensate for long-lived CO2, you need a credible, durable mechanism established today to ensure that compensation is maintained or replaced over the centuries. This could be things like dedicated financial reserves, insurance pools, or contracts for future durable carbon removal.
Basically, you need to guarantee the funding or the physical removal long after the initial transaction.
Precisely. Someone has to hold that long-term climate mortgage.
That's a profound shift in thinking. Okay, principle 4.
Principle 4. Align accounting with source and context. This is about differentiation. Not all methane emissions are created equal, nor are all mitigation options. The accounting needs to reflect the specifics of the sector, the region, the socioeconomic context.
Why is that so important?
How?
Methane is methane, chemically.
Chemically, yes, but think about the source. Methane leaking from a natural gas pipeline is essentially industrial waste. It's often relatively cheap to fix, and efficiency loss. Methane from cows burping enteric fermentation is deeply tied to global food systems, agriculture, livelihoods, even culture.
So the economics, the politics, the social implications of tackling them are vastly different.
Totally different. If your accounting system treats them as identical fungible units, what happens? Money will flow to the cheapest, easiest fixes, probably plugging some industrial leaks.
Which is good, but...
But it might draw focus and funding away from the harder, more systemic challenges like transforming agriculture or developing alternative proteins. It risks incentivizing only temporary fixes, not structural change.
And it could mess with sector-specific policies, too.
Yes. For example, if oil and gas companies can easily buy cheap agricultural methane credits to meet their climate targets, it might reduce the pressure on them to implement regulations to stop their own leaks. Or if credits for plugging orphan wells get sold off to airlines, it might undermine dedicated government programs designed to fund that specific cleanup task. context matters.
Got it. And the final one, Principle 5.
Principle 5, enable innovation within clear boundaries. Look, we absolutely need innovation in this space. New technologies to detect and reduce SLCPs, new ways to finance projects, maybe even new accounting approaches. We shouldn't stifle that.
Right.
But that innovation needs to happen within clear, strong boundaries that protect transparency and ensure real climate benefits. We can't let innovation become an excuse for weak standards or opaque methods.
So how do you ensure that?
Key elements are things like adaptive management, being willing to update rules as science improves, requiring independent third-party review of projects and methodologies, and insisting on public access to the underlying data and assumptions. Transparency is the antidote to potential gaming.
And we're already seeing innovation help with transparency, right?
Absolutely. Think about satellites and airborne sensors now tracking methane emissions. Organizations like the International Methane Emissions Observatory, IMEO, and its Mars initiative are using this tech. It's shown that previous estimates, especially for oil and gas methane leaks, were often way too low. And crucially, making this data public empowers governments, researchers, and even citizen groups to verify industry claims and push for action. That's innovation working within strong boundaries.
Okay, so those 5 guardrails,
Yeah.
separate tracking, matching duration, long-term accountability, context awareness, and bounded innovation, provide a pretty robust framework.
They do. The overall conclusion from our sources is clear. Cutting SLCPs, especially methane, is incredibly important. It's probably our best lever for slowing down warming in the near term, buying us time.
It's a vital complement to cutting CO2.
A vital complement, yes. But, and this is the crucial takeaway, it is not a substitute for the deep structural decarbonization needed to eliminate long-lived CO2 emissions. That remains the core challenge.
And these guardrails are designed to make sure that SLCP action strengthens our overall climate strategy, rather than accidentally weakening it through accounting tricks or loopholes.
Exactly. They ensure the integrity of claims like net zero.
So, to leave our listeners with something to think about.
We've talked a lot about this idea that climate liability, the warming caused by today's CO2, lasts far longer than the companies or even governments making promises today. If we start relying on temporary methane cuts now, with the assumption that maybe future generations will deploy large-scale carbon dioxide removal later to truly balance the books, what kind of governance structure, what kind of legally binding financial mechanism do we need to put in place today to absolutely guarantee that future action happens centuries from now? Who holds that multi-century contract?
That's a heavy question. Who indeed? Definitely something to chew on. Thanks for walking us through that complex landscape.
My pleasure. It's critical stuff.
That's all for this deep dive. Join us next time as we tackle another set of sources.